Alright, so this is segment lengths notes. I will say this. The stuff that we did all last week was all about angles, central and inscribed angles. Then the arc measures and stuff that we found, that was all angle stuff that we did last week. This week is just going to be about finding the length of a segment, dealing with the chords and the sequence. So I say that to start by saying this, like, we're not dealing with 360 or 180 or 90 or none of that stuff. We're not dealing with angles today. It's just straight up finding lengths. It's almost kind of like writing proportions, except for we're not going to make ratios. You'll see what I mean as we go to. We're just going to be kind of matching up segments and finding missing lengths. Alright, the first theorem I'm going to teach you is about chords in a circle. Segments of chords theorem. If two chords intersect at the interior of the circle, then the product of the lengths of the segments of one of the chords is equal to the product of the length of the segments of the other chord. Product meaning the answer to multiplication, so we're going to be multiplying. It's very simple. You just got to watch how it match up. I think the kids at last class were kind of surprised at how easy it was. It's pretty simple stuff. They're saying the product of me multiplying the two segments on this chord right here together, A to E and C to E, is equal to me multiplying the product of these two segments on this chord right here, B, E, and D, E. One thing I will say, these intersections, they're not at no midpoint or nothing, so this ain't equal to this, and this is not equal to this. You can really tell that too, especially for this one. You can tell that B to E is longer than D to E. This ain't no midpoint situation at all, like we've learned before. It's not that. It's just saying that this segment on this chord times this segment on the same chord is equal to this segment times this segment. It's pretty much what they're saying. So to write it out, A to E times C to E is equal to B to E times D to E. And based on what you're missing, you will write that out and solve. That's pretty much the formula. Give you a chance to write that real quick, and then we're going to go straight to solving. Rolling. The first one. Solve for X. All I'm doing is matching up this segment right here with X on it times 40 should be equal to 24 times 30. So X times 40 is equal to 24 times 30. Do the math. 40x equals 720. Divide by 40. On this first one, x equals 18. They found it pretty easy last class, so you should. Oh no, I just paused the screen. Delgado, what we got? Thank you. I heard you said thank you. Moving on. Number 3. Same thing, just now we adding expressions. If I only got one variable, I'm always going to keep it on the left. So I'm going to do 14 times this expression, 2x plus 10 equals 16 times 21. I'm not saying much because I ain't saying much to say. Y'all been doing this with me long enough now. Number 4. Same thing. It's just got 2 expressions on it. It's really up to you how you roll with it. Oh, I'm messing that up. 10 times x plus 1 equals 8 times x plus 4. Number 5, find AB. Same thing, we just got to plug back in for AB after we finish. So I'll do number 5 with you. After you get x is 9, you need to plug back in for AB. AB is going to be x plus 7 plus 21. So 9 plus 7 plus 21. Use number 5, solve for number 6. What you got for X? What you got for ST? Alright. I ain't show my work at all. I'm assuming y'all had it. And we go on to the back. On the back, these are exterior intersections. You have two types. First type, you're going to have where two secants meet and create that exterior angle like we've seen before. But we're not worried about the angles no more. We're worried about the segments. Alright. The first one, segment of secant theorem. If two secant segments share the same, forgot the word, hold on, endpoint, outside of the circle, then the product of the lengths of one of the secant segments and its external segment equals the product of the lengths of the other secant segment and its external segment. That's a lot to say this, what they're telling you in so many words. Let me show it to you over here. The way you write this is going to be a little bit different. So they're saying on this first secant line right here, AC, they're saying for the theorem, AB times AC would equal this other secant, AD times AE. Let me write that up. They're saying from A to B times A all the way to C would equal AD times A all the way to E. Let's use it. Let's stay there. I'll zoom out a little bit so you can see it. Alright. On this first one, my first secant line right here, I'm going to write it like this. 14 times parentheses 14 plus 30 equals 16 for my other secant line times in parentheses 16 plus x. After that, it's just about doing some math. On this side, you could distribute if you wanted to, but it's all numbers here, so I would just add that together. But distributing will get you the same thing. I'm only really just going to distribute over here, though. On this side, I'm going to do 14, then I'm going to add 14 and 30 together, 44. Over here, I'm going to get 16 times 16 is 256. 16 times x is 16x. Zoom in a little bit more. 14 times 44 is 616. 256, 16x, two-stepping. If your work is correct, you can get decimals on here. Or x equals 22.5, whichever way you want to write it. Number 8. Same thing, just gotta write the equation correctly. On this one though, they got expressions in, so check out how I write it. I'm gonna start on this secant line over here. It don't matter though. So I got 7 is my short part times the whole secant line. I'm gonna write it like this: 2x plus 3 plus 7 equals 6 times 4x minus 1 plus 6. Clean that up. Last thing. Secant and tangent theorem. So this theorem is for if you have a secant and a tangent line on a circle, create an exterior angle. If a secant and a tangent segment share an endpoint outside the circle, then the product of the lengths of the secant segment and its external segment equals the square of the length of the tangent segment. Moving over to show you the formula. It's not hard. Part of it is going to be the same as what we just did. The new part is going to be the tangent part. So you got a tangent line right here, AB, and you got the secant line right here, AD. For the tangent line, this is where they say you're going to square it. So it's going to be AB squared equals, and this is part is going to be like what we did up top here, AC times AD. Number 9 says solve for x. Okay. My tangent line is 21. 21 squared equals 15 times 15 plus x. (21 squared) is going to give me 441. 15 times 15 is 225 plus 15x. What you got for X, Marcus? Oh, well, thank you. Number 10. Tangent line is 24. It's going to be 16 parentheses 7x minus 1 plus 16. (24 squared) 576. 16 times 7x 112x. 16 times 15 is 240. Somebody asked me to do number 8 on the home learning, which was fine. Y'all don't really need me to do it, but I'm going to do it anyway. Just so you won't have no excuses. And number 8 says solve for x. Round to the nearest tenth. If necessary, hint, hint. Kind of hinting that it's probably going to be a decimal. This one, tangent line, secant line. Tangent line is x squared equals 28 times, in parentheses, 28 plus 50. Once you do the math on that side, x squared, square root, to the nearest 10. Thank you. Alright, you should be good. Handle your business.